Okay, welcome back, guys. We're going to be looking at test 5 at this time. So if you want to have that in front of you, if you need to check any that you did just to see if the answers are correct, or if you were struggling on any that you needed help with, I'm going to work through all of the problems, but you can feel free to fast forward through to wherever it is that you need to be. You don't have to watch the entire video unless you want to. All right, so number 1, let's look at the first one. And by the way, between test 4 and test 5, you had a total of 28 questions instead of the total 40. So I did try to scale back so you didn't have to do the entire 2 tests. I tried to pull the problems that I felt were best to pull from each test. So let's go ahead and get started. Number 1, the formula requires 20 liters of alcohol to make 120 liters of solution. How many liters of alcohol are needed to make 1,560 liters of the solution? So what we're going to do for this problem is we're going to set up a proportion. So let me go down to the bottom here. We'll start. I'm going to change my pen color to something different. We will use, oh golly, let's use a different color blue. This is number 1. So the proportion is going to look like this. We're going to take the 20 liters of alcohol and we're going to put that over the 120 liters of solution. Because that's what the problem says. It takes 20 liters of alcohol to make 120 liters of the solution. Now let's write the proportion here. The other side of that is we don't know. We're trying to find out how many liters of alcohol, so we'll call that A, it takes to make 1,560 liters of solution. Okay, so those are matching. That's a proportion because it's set up in direct proportion to the one is set up in direct proportion to the other. So let me simplify this down so you can see what it's going to look like. So we have 20 over 120 equals A over 1,560. Excuse me. So we're going to do, we can do cross products here. I wanted to see what I did here. Yeah, that is what I did. Okay. Scared myself for just a moment. So we're going to do cross products where we multiply directly across. So we have 120 times A equals 20 times 1,560. And 20 times 1,560 is 31,200. You can test it in your own calculator to double check me. We divide both sides by 120, and that's going to give us the amount of alcohol needed to make 1,560 liters of solution. And that should come to 260 liters. And that's the answer to number 1. Number 2, let's bump back up here to the test. That's number 1. Let's look at number 2. Less than half of the students missed the chemistry demonstration. In fact, only 3/10 of the students missed the demonstration. If 21 students did not miss the demonstration, how many students did miss the demonstration? So that's a little bit confusing. I'm going to leave the problem set there for a minute. I'm just going to write some information right down here in this little open space that I have. Okay, so let's write down what we have. So we have 3/10. Actually, you know what? You have your test there, and I have a paper copy here. So I am going to go down here so I don't run out of room. But let's talk about the parts of this. Okay, so 3/10 of the students missed the demonstration. So we're going to write that like this. I just want to get some information down here. That means what is the fractional part of the students that did not miss the demonstration? Well, if 3/10 missed, then that means 7/10 did not miss, right? It would be the remaining amount. Okay, we don't know the number of students that missed. As a matter of fact, that's what we're going to try and find. The number of students that missed. We know that it's 3/10 of them, but I don't know what number represents the 3/10. We are told that 21 students did not miss the demonstration. Okay, so first of all, step 1, we need to find the total number of students. What's the total? We don't know. The only number of students we know is the 21 students who did not miss. So we want to find what is the total number of students. Okay, so I can take what I do know, and I know the most information that I know exists right here, the 7/10 and the 21. So I'm going to use those two to say, all right, then let's figure this out. 7/10 of what number is 21? So once I figure out that's 7/10 of what number, once I figure out that total number right there, then I can apply that to the number that's of the students that missed the demonstration. So let's work this out. So I'm going to multiply by the reciprocal here. Oh, good. I love when I can cross cancel like that. These cancel out, and I'm left with the number is 30. So the total number of students, is 30. That's helpful to know, because on step 2, we're going to take that 30 and we're going to subtract the 21 that did not miss. So look, we're taking our total students, subtracting out those who did not miss the demonstration, and that's going to give us the total number of students. So 9 students did miss the demonstration. So the answer then would be 9 students. So we just figured out this part right here is 9. Okay, and that's how you do number 2. So let's look at number 4. That's the next one on our list. Okay, so we're going to use this, in fact, I'm going to go ahead and just do this right on the test here. We're going to use elimination to solve the systems of equations, which means eliminate. So we want to eliminate one of the variables so that we can solve for the other, and then we can take the value that we get and plug it into one of those equations. Now remember what a system of equations is. What that means is that with these two equations, they're going to come up with an x and a y value that will actually satisfy the equation, both of those equations, using the same solutions. That's what a system is of equations. So I investigate by looking at this and think, well, which one would be best to eliminate? Because when I look at 2x and 3x, when I add those together, because that's what we're going to do, we're going to end up adding these equations, but this would give me 5x, and this would give me negative 2y. So I didn't actually successfully eliminate anything. So in order to eliminate it, I would really need, it would make sense if maybe this was a 3y, because then I could eliminate this by going 3y minus 3y would give me a 0. But how am I going to make that a 3? Well, that's easy. Let's multiply each term in here by 3. We'll just increase the equation. We'll keep it balanced by making sure that each term gets multiplied by that 3. So we'll have 6x plus 3y equals 48. And then we can just leave this next one as it is. We'll have 3x minus 3y equals 15. Now we're going to put those together. So 3y minus 3y eliminates. I'm going to have 9x equals 4, 5, 63. We divide both sides by 9. I have x equals 7. Okay, so there's one solution. Now I'm going to take that x value and I'm going to plug it into the simplest of equations. Usually I pick the easiest one, so I'm going to take the first equation. And the reason I would pick that one is because I notice it has just a y term in there. It'll just make my math a little bit easier. So I'm going to draw a line here, and I'm going to rewrite just the first one as it originally appeared in my system. So it was 2x plus y equals 16. And I'm going to take x, we said is 7, and I'm going to put it in here for x. So 2 times 7 plus y equals 16. 14 plus y equals 16. Subtract 14 from both sides. And y equals 2. So, through the process of elimination, or just elimination they call it, the answer would be for x is a 7 and y is a 2. That's how you write the answer to that. Okay, that's number 5. Let's go up here or 4, excuse me, that's number 4. We need to look at number 5. All right, number 5, we are going to add together those 3 terms. So I'm going to rewrite them down here on the bottom. Number 5 is a over c squared minus a minus 2c over 3a squared. Alrighty, here we go. Okay, so in order to put these together, I'm going to need to have the same denominator. This is like subtracting fractions or, combining fractions. So I need to have the same denominator. And I notice here, I don't have one at all with my second term in there. It's just an a term. So let's decide, first of all, what does that denominator need to be? Well, in order to use all the terms and make them the same, it looks like I'm going to use 3a squared c squared as my common denominator. So how can I change that up to make that read 3a squared c squared on each one of them? Well, the middle term is going to be easy because that's going to be everything needs to change here, right? I don't have anything. So 3a squared c squared, I need to put the whole thing in there. And remember, to keep it in balance, you have to do the same to the top. Okay. And actually, there's probably an easier way to do this. I'm going to go ahead and continue with it this way, but I think if we multiply everything by the common denominator, we can quickly get rid of some things in the denominators of those fractions. But let's go ahead. Since I've started this way, we're going to go ahead and finish it out this way. Okay, so the first fraction, a over c squared, I need to multiply with a 3a squared in order to make the denominator of 3a squared c squared. And we have to do the same thing to the numerator, so 3a squared. And over here, we want to multiply with c squared. And now let's do the math for that. So this one turns into 3a to the third power minus, we know the whole thing's going to be over that common denominator, 3a squared c squared. So we're dealing just now with the numerators of each one of these. So now I'm going to have 3a to the third power c squared minus 2c to the third power. And that's the answer to the problem. Okay, just for the fun of it, I'm going to go ahead and I want to just try this myself. If you don't need this or you're not interested in seeing this, you don't have to land here. But for those who have that mathematical mind and you like to kind of see different methods, let me just show you this. I'm going to try this together with you. Okay, so I'm going to take that common denominator of 3a squared c squared, and I'm going to just multiply everything. I'm going to increase each one of those I'm going to multiply each term with 3a squared c squared. Okay, so 3a squared c squared, and the same thing here. I'll put it in parentheses so you can see it's being multiplied. 3a squared c squared. So all I'm doing is increasing each term by that term, 3a squared c squared. The cool thing is what happens here, I want to look and see if this works out. Spin a little bit. No, that's not actually what I want to do, is it? Because if I do that, I'm going to lose my denominator. So I would have 3a squared to the third power minus 3a to the third power c squared. I'm going to get the numerator, but the denominator just kind of disappears, and that would not be correct. So I have to think about that now. Seems legal what I did. but I did lose my denominator. So I might have to do a little more investigating on that. So let's go ahead and just get rid of that. Sometimes I like to try things with my students just so we can work through them and see if they work. And I will spend a little more time on that myself because I'm curious about that now. Okay, so that is number 5. Now let's look at number 7. Number 7, we want to graph these two equations. So I have y equals -2. So we'll go down here on a coordinate plane, and we're going to graph y equals -2. And as you know, we saw something like this earlier. We just find -2 on the y-axis, and that is y equals -2. Okay, so you find your point at -2. It's a horizontal line. X does not change, but y does not change, x is changing. Okay, so it's a horizontal line at y equals -2 is going to be your equation. The next one is y equals -3x. So I'm going to write that right here. All right, so think about that. Remember, we've been talking a little bit about that slope-intercept form, mx plus b. Okay, so I have an m. I know the slope is -3, which, by the way, will be -3 over 1. Right, that's my slope. But I don't know what the b term is here because there's nothing written here in this equation, y equals -3x. So what do you think it must be? In order to not change the value of that, can I just call it 0? And remember, the y-intercept includes that 0. So it's the y value of the y-intercept. Okay, so the point is at 0, 0. Because remember, if it was -3x, just as an example, plus 7, that's the y value of the y-intercept at 0, 7. Okay, so that's how you use the b term. Okay? Now, so we know we have a point for that line, and we know the slope is -3 over 1. And remember, that's rise over run. -3 over +1. So from my point on the y-axis, my y-intercept, I'm going to rise -3, which means I'm going to go down 3, 1, 2, 3, and over 1. And I'm going to draw my line. And that is the line y equals -3x. I didn't draw my line perfectly because it's hard to, but if you have a ruler, you can make it look a little nicer. Okay, so that's how you graph those two lines using your y-intercept form. Number 7. Let's move to number 8. Find the equation of the line that has a slope of -2/3 and passes through this point. So we know this point is on the line. So let's go down here and plot for -3. Use this one here. For -3. 1, 2, 3, 4. 1, 2, 3. For -3 is right here. And the slope we said is -2/3. So m equals -2/3. So that's rise over run. And remember, it doesn't matter on a negative fraction. It doesn't matter if you choose this as the -2 and this as the +3. It can be that, or it can be the 2 is positive and the 3 is negative. It doesn't matter because remember, either one of those ways makes the whole fraction negative. So you can choose which way you want to go. I'll go ahead and rise. I'll choose this one. I'm going to rise 2, 1, 2, and over to the left, 3, I'm going to run. 1, 2, 3, right here, right? So we rise 2, and we run -3. And then I plot my point there, and I connect it as my line. That was number 8. Oh, wait a minute. What are we supposed to do? Uh-oh. Did I need to do that? 8. What am I trying to find? Oh, oops, find the equation. Okay, well, that's all right. Yeah, I graphed it. It didn't say you had to graph it. I do apologize. So we want to find the equation for that. Well, that was silly, wasn't it? Okay, well, anyway, you got a little information there. So let's look at this again. So we have a slope. This is number 8. The slope equals negative 2/3. And the line passes through for negative 3. There we go. Okay. So we're working with the slope-intercept form. Y equals mx plus b, where m is the slope and b is the y-intercept, or the y value of the y-intercept. We're going to take these points and use those as an x and y value in our equation, and we're going to substitute those in, because what we need to find is we need to figure out b. I don't have the y-intercept given in this problem, and in order to satisfy this and write that equation, I have to have b. So let's go ahead and put in, I know the slope is negative 2/3. Y is going to be negative 3. We're going to substitute these in, and x is 4 plus b. Let's do the math here. I'm going to have negative 8/3 plus b. I'm going to put this over 1, because what I'm going to need to do is make this over 3. So I'm going to have 9/3 on this side equals negative 8/3 plus b. Let's add 8/3 to both sides. And I'm going to end up with a negative 1/3 equals b. So now I know that b is negative 1/3. So to go back up here and write that into this equation right over here, it's going to be y equals our slope of negative 2/3 x minus 1/3, because our b down here was negative 1/3. This is the equation to the line that has a slope of negative 2/3 and passes through the line at 4, negative 3 on your coordinate plane. That's the answer to number 8 right here. All right, let's go back up here and see what's left. We have quite a few yet. Number 9. This was a fun one. I kind of thought that you guys might enjoy this one. Number 9. I'm going to try to work with it right here because I don't have to rewrite it out. All right, so we have to find a, x, and y. So let's look at this thing and see what we can figure out. Well, first of all, I see a line here with 3 angles making a total amount of 180. So could I, to find a, could I just add 65 and 90 and then find a that way by subtracting those from 180? In other words, we would go 65 plus 90 plus a equals 180. Since that makes those linear, it's all on a line. They total 180. So you would have 155 plus a equals 180. If you work through that and subtract 155 from both sides, you'll end up with a equals 25 degrees. Okay, so that's a. Now we have to find, that's number 1, step number 1 for a. Now let's look over here. I'm going to do number 2 over here, and I'm actually going to try to solve for the y value now. Now I notice, I'm going to erase something so I don't get too much confusion going on here. I'm going to get rid of that arc, and we're going to put, we're going to identify here that we have vertical angles, okay, which tells me that, oh, and we know this is 25 now, right? So negative 6x minus 7y is equal to its vertical angle of 25 degrees. And looking here. That's not actually what I did, but that is what I'm going to do now. Oh, you know why? Because I remember why. I did this two different ways, because in the Saxon answer key, they actually want you to see a system of equations here. This and this. Because, see, and that wasn't my first go-to in my brain. My first go-to was to identify vertical angles, which doesn't make there anything wrong with that. But since vertical angles, okay, are equal, so you have this set is equal to this set, 5x minus 10y is equal to 90, I can actually write this up. Actually, let's go ahead and do it that way. So I'm going to use a different green because that's not really dark enough. Okay, so you have here we go. All right, so I'm going to write down negative 6x minus 7y equals 25. That's already there. And then 5x minus 10y equals 90. It's a system of equations. Now, you could actually solve, you could actually have solved, oh, actually, no, you would not be able to. That's right. Yeah, so we're gonna use this to solve for y. That's right. Because you have two variables in that expression, it makes it a little bit harder, even though you know a is 25. It doesn't make it easy to figure out. You have to have a system that works, excuse me, that's going to actually solve for one of the variables so you can go back and substitute it in. So let's use elimination to do this. And we can look at our terms and think, what's going to be the easiest way to handle this? So what I did is I multiplied the first one by 6. And I multiplied the second one, all the terms, by 5. So what I'm shooting for is to make my x terms opposite way around. And now I'm a mess. It's Thursday night and I'm getting a little bit tired, I think. Okay. On my sheet, I have them written the other way around. So here we go. So we want to multiply by 6 here. And then I'll make this one green just so it stands out. And 5 here. Okay. So what I'm shooting for is to make my x terms negative 30 and 30. So that when I eliminate, I have something to eliminate. So here's the way this is going to roll. So I'm going to use blue now just to rewrite the whole thing. Okay. So if I multiply all my terms up in this one by 5, I'm going to have a negative 30x minus 35y equals 125. And then the second one here, I'll do this one now, I'm going to have 30x minus 60y equals 540. Now let me just double check, make sure I have that right. Okay, now I can take that system and eliminate my x terms and have 95y equals 665. We'll divide both sides by 95. And my y is going to end up equaling negative 7. Okay, now I'm going to pick one of those easy equations up top there. This was the first thing we did. This is step 2. And now for step 3. Gotta find a spot here, right over here. Okay, so I'm gonna pick one of those original equations. I'll go ahead and just pick the second one that's in green. I'll put that in green over here so you can see where I'm pulling it from. 5x minus 10y is the original equation in my system of equations here. I know that y is negative 7, so I'm gonna put that in and I'll solve for x. 5x plus 70 equals 90. And we just work this through with our algebra knowledge. So there's my x value and my y value. And remember how we write this? 4, -7. And that is your final answer. 4, -7. And we also knew that a was equal to 25. That was the other part of that. I was looking for all three of those. So we had -25. We can just put up here so you can keep them all together. -7 and was it 5? 4. Okay, 4. And there's all three answers for you. All right, that's number 9. Boy, the problems get long in Algebra 2, don't they? Okay, number 10 is here. Find the area of the sector shown. All right, I'm going to try to just do this so I can use the shape right here. All right, so we're looking for the area of the sector. Dimensions are in centimeters. So let's put centimeters right here so we don't forget that. All righty, so how do we find the area of a sector? It's a part of a circle, isn't it? If I were to finish this around, that's not a perfect circle, but that's the idea. It's a circle, right? A part of a circle. I know that the the degree measure of the angle there, the central angle, is 135 degrees. And that is a part of our 360-degree circle. So we can find for the area of a circle, we're going to use pi r squared. That's the area of a whole circle, right? And we want to multiply this with the fractional part that our sector is. Well, how do I figure that out? Well, I'm going to take 135 degrees because it's 135 degrees out of the full 360. And yes, we can actually simplify that fraction to make our math a little bit easier. We will calculate pi in just a moment, but for now, let's go ahead and fill in our part. So we have a radius down here of 10. So it's pi r squared, or 10 squared, times, and if you simplify this down, you're going to end up getting 3/8, by the way. Okay, so this sector is 3/8 of the entire circle. So I'm going to have 100 pi, or 100 times 3.14, times 3/8. Let's do a little math here. So I'm going to have 314 times 3/8. When you do the math on that, you're going to end up with 942 over 8. And your final answer, when you put that in your calculator, 942 divided by 8 is 117.75 centimeters squared. And that is the answer to number 10. Okay, getting a little messy here, huh? All right, let's look at number 11. We have to expand this thing. I'll go down to the bottom. I'm going to rewrite it down there. We'll work it through together. M. Let's get a new sheet. M, n to the 0 power, n to the -2nd power, times n to the -2nd power, times, boy, they sure do pick variables that can make your brain a little bit batty. 2m to the 3rd times n to the 2nd over m n to the 3rd. There we go. All righty, let's roll. All right, this is a lot of writing out, but in order to do it well and correctly, it's not a bad idea to write it out. Be careful about doing too much in your head. Now, the first thing I want to notice here is I'm going to take a look at this fraction here and see if there's anything I can go ahead and simplify right out of it. I have m and I have n to the 0 power. And remember, n to the 0 power is just 1. So I'm just going to cross it out because it becomes 1. And 1 times m is m. On the bottom, we have a base of n on both of those. with an exponent of -2. So if I put -2, remember I'm going to add those together, and I add a -2, I'm going to end up with, oh, I'm sorry. That's a +2, isn't it? I think I wrote that down wrong. Let me double check. Yes, I'm sorry. It is. Okay, good. That makes it a little bit nicer. So this should be n to the second power. So it's going to be 2 minus 2. Remember, when you have multiplication of exponents with the same base, you just add together your exponents. So 2 plus a -2 is the same as 2 minus 2, which is n to the 0 power. And I'm looking here because I'm noticing in my work I'm forgetting things. That should be a negative. And so that's a negative. Okay? I'm sorry, guys. I may end up having to cut this short and do the rest of it tomorrow. I can tell I'm getting a little bit tired. Okay. So the next part of this is, it doesn't look like I can do anything with the fraction that's inside the parentheses to start with. But now let's look at the second set over here. Is there anything we can do? Because I notice there's an m up top and there's an m on the bottom. So I'm going to put a 1 here. Remember, when you divide m's, it's like they cancel out. So it would be m to the third on the top and 1m on the bottom. This one's going to go away, and this is going to become a 2. So 3 minus 1 is 2. And let's look at our n terms here. So now I have 2 minus 3 is going to give me a -1 up top here. Okay, so let's rewrite this thing down below. So I have 2m to the second power times n to the -first power. And that's what I have. And I'm going to go ahead and put that over 1, just so I have something down there. Okay, so now let's look here. I have m over negative. That becomes a 1. Anything to the 0 power becomes a 1. Don't get rid of the negative sign. That needs to remain. And inside here, I still have m. We're going to take care of combining those in just a moment, but I like to go a step at a time so I don't lose you. Minus 2m squared, and I'm going to move this to the bottom. N to the first power, or just n. Okay? The next step, we can go ahead and multiply these out. So I'm going to distribute. So the first term would be m times, distributing this right here. So I'm going to have m squared over negative n to the third power. And I'm going to do the same thing to this term. And keep in mind, this is negative here. So since I have a negative out here, it's going to make it plus, right? So it's going to be 2m to the third power over n. And that's your final answer right there. Okay, that's number 11. Let's see how many more I have to go. I'm going to try to keep plunking away here so we can try to get it done. Number 12, this might take a whole hour, I don't know. All right, we're going to solve for the unknown variables here. So I have R-A-T-A, it looks like rata, R-A-T-A plus R-B-T-B equals 300. There's our equation. We know that RA is equal to 60, so we're going to do some substituting here. RB is equal to 12, and TB is equal to TA plus 7. So we're going to substitute in where we see these terms. So watch this. So RA is 60. TA, we don't know. RB is 12. TB, we're told, is TA plus 7. So you can see where this is heading. We're going to be able to solve for TA here. And once we know TA, we can substitute that in to figure out TB. So let's keep going. Whoa. Gracious day. All right, so let's go. So we have 60 TA plus 12 TA, I'm distributing here, plus 84 equals 300. I'm going to combine like terms where I can see that I can do that. Over on the right-hand side, you're going to have 216. On the right-hand side, I can put together 60 TA and 12 TA for 72 TA. Divide by 72 on both sides. And T sub A is going to be equal to 3. If you put that in your calculator, TA is 3. Now from there, so that was the first thing we do. The second thing we do, I'm going to put a little line here, is we solve for TB. And notice TB up here is equal to TA plus 7. So let's put in 3 for TA, and you're going to end up with 10. So there's your two solutions, 3 and 10. Okay, let's look at the next one. 10, 11, and 12. 13, we want to multiply this right here, 3x minus 2 times 4x squared minus 7x minus 5. So I'm going to come down here, I'm going to change the color of my pencil to blue. And let's write it down. Number 13. 3x minus 2 times 4x squared minus 7x minus 5. Let's go ahead and finish this one. And then I think I'm going to make yet another video only because I think it will take too long to try to upload it. So I may have to cut it short and then finish it up on another one. Okay, so I've got this term here, quantity of 3x minus 2, that's going to be multiplied with a larger quantity. So when we do this, you remember, I'm just going to distribute. I'm going to take this 3x, I'm going to start with that, and I'm going to multiply it. I'm going to distribute it to all 3 of the terms in here. Okay, so 3x times 4x squared would give me 12x to the 3rd power. 3x times a negative 7x is going to give me a negative 21x squared. And 3x times a negative 5 is going to give me a negative 15x. And then I'm going to take my negative 2 here, and I'm going to multiply it with each term inside this parenthesis. So I'm going to end up with negative 2 times 4x squared is a negative 8x squared. Negative 2 times a negative 7x is going to be a positive 14x. And negative 2 times negative 5 is a positive 10. So there's all the terms multiplied out, and now I can find whatever like terms I have. So let me get a yellow highlighter here. And let's see, so 12x to the 3rd power is the only exponent of 3. I have a negative 21x squared and a negative 8x squared that I can combine. So let's do those two together. You're going to end up with, let's put 12x to the 3rd power down here. And you're going to have a negative 29x squared. Let's find another highlighter color. We'll take green. I have 2x terms here. Let's put those together. Negative 15x and a positive 14x gives you a negative x. And then lastly, I have this plus 10 on the end here. And that is final. Once you have no other like terms, you've completed the work. So number 13, there's your answer for that. And I'm going to go ahead and cut this off right now and put part 2 up. You'll find part 2. If you need anything beyond 13, you can find it there, okay?